This is part 4 of a video series created for student teams studying external aerodynamics of a 2 diameters rocket. This part will help you to understand your simulation. You will also learn how to check if the simulation is converged and how to interpret your results. As a quick reminder, post-processing is the fourth step. In general, the solver must perform enough iterations to achieve converged solution. At converged solution, all conservation equations like momentum and energy or the other equations that you have must be in a specified tolerance. Overall mass, momentum, and energy must be balanced, and your target quantities must reach constant values. In this part, I'm going to show you how to do some of the post-processing inside Fluent related to your model. Okay, in the previous part, we started the simulation. And when you start the simulation, you'll see the residuals plot on one of the windows. In general, residual measures the imbalance of the current numerical solution, and it can be related to but not equal to the numerical errors. Besides of the residuals, we can also look at the quantity of interest, which was drag forces over the rocket walls. And you'll see that after 400 iterations, drag force is really stable. We can also look at the overall mass and momentum and energy in the model. We can go to fluxes, it's under results, and then, for example, look at the mass flow rate at far field boundary condition and then compute. So you see that it's very small mass flow rate and it shows that it is balanced. You can also repeat this one for heat transfer if you have defined temperatures for your boundary conditions or you are considering heat transfer in your model. Let's say your model is very good and you want to save your model for future analysis. To do that, you can just go to File and then write Case and Data files. For post-processing, you can create several contour plots or vector plots. You can find contour plots under Results. So just double-click on that. And then you can define the variables that you want to make contours. Let's say we want to look at velocity and velocity magnitude on the symmetry planes. And then display. You can rotate your contour plots, or you can just choose the direction from the axis. You can name your contour plot here. You can also exclude global range and then just go for the auto range. When you're choosing global range, it's going to show you the mean and max in the entire geometry. When you are going for the auto range and excluding global range, you're going to see the mean and max in the selected surface or surfaces. You can also define your range by deselecting this one and then just put a range that you want velocities. You can zoom in or zoom out in your contour plots. We can go to View and then just turn off the lighting. We can create new planes. Let's say we want to have a plane between two symmetry planes. You need to go for 3 points and then just rotate and move and then create. You can also draw mesh inside the contour plot. When you are drawing your mesh, you can change the color and it's recommended to go for light gray. You can also turn on the lighting and then just add the contour lines. You can also go to Views and then create mirror planes. Choose the symmetry plane and then apply. From the velocity contour plots, we can understand about the velocity gradients around the rocket wall, and also you can have a better understanding of the influence of rocket diameter transition on the velocity gradient, or to know what are the vortices in the rocket wake region. You can have the same contour for the pressure. Instead of the plane, you can also have the pressure distribution over the rocket wall. You can have similar vector plots to look at the velocity on symmetry and then display. We can also create path lines. And then perform surface or volume integrals. You can choose area weighted average and then wall fluxes, wall shear stress, and then choose the surface, for example, rocket wall, and then compute the amount of wall fluxes over the rocket walls. You can also compute forces. Choose the wall zone, and then correct direction, then print. These are the forces from the pressure and viscous. You can also compute center of moments. You need just define moment center and then the moment axis, which is in the y direction, and then the wall zone, and then print. You can go to results and then choose plots. Go for XY plot. For example, you can plot the y plus values over the rocket wall. To find y plus, you can go to turbulence and then find wall y plus, and then choose the surface and then correct direction, and then plot. You can also repeat the plot for wall shear stress. To find the wall shear stress, you can go to wall fluxes. You can also create scene to overlay several contour plots or vector plots on top of each other. You have an option of creating animations or creating reports. You can also have access to the help. You can just hit the question mark and then it will directly go to the help of that page. Thanks for watching this video series.